Hi everybody, it's Fahad here, and today we are going to discuss an interesting wireless communication protocol. Since last few years everyone has been talking about how Internet of Things will change our world. But have you ever wondered at how we're going to address the challenge of connecting billions of devices? The current available wireless networks like Bluetooth, Bluetooth Low Energy, Wi-Fi, and Zigbee are not suitable for long-range applications. Cellular networks too can be used for remote machine-to-machine communication because of high battery efficiency. Overall, all these networks are very expensive as far as hardware and software services are concerned. So a low-power wide area network is required for such applications. If this interests you, bear with me for the next 5 minutes as we are going to discuss LoRaWAN today. LoRaWAN is a low-power wide-area network that enables low-power wide-area communication between remote sensors and gateways connected to the network. LoRaWAN addresses some of the key challenges that are faced by Internet of Things. These challenges include secure bidirectional communication, mobility, and localization. LoRaWAN addresses all of these challenges without the need of complex local installations. One of the key features that the LoRaWAN technology offers is the ability to communicate over long ranges. A single gateway or base station can cover entire cities or hundreds of square kilometers. Range is entirely dependent on the environment or obstructions in a given environment and therefore varies geographically. In any given environment, link budget is one of the key parameters for determining range. LoRaWAN has a link budget greater than any other standardized communication technology, which explains its suitability for IoT configurations. Typically, its range varies from 2 to 5 kilometers in urban areas and 15 kilometers in suburban areas. LoRaWAN has wide usages that range from smart city applications to applications that require real-time monitoring. LoRaWAN has shown key success stories with smart lighting, smart parking, and smart waste collection, thanks to their scale and the nature of the data generated by those applications. These encompass periodic messaging with certain delay tolerance. For example, smart parking applications report the status of the parking spots upon a change is detected. LoRaWAN is an appropriate technology for this use case since it handles the wide coverage area and a significant number of users. Real-time monitoring is just another example of the wide usages of LoRaWAN. Agricultural, leak detection, or environment control are applications with a reduced number of periodic or aperiodic messages and relaxed delay constraints. In contrast, the communication range must be long enough to cope with dispersed location of end devices. LoRaWAN has been designed to handle the traffic generated by this type of applications and meets their requirements as long as the deployment of the gateway is enough to cover all end devices. Companies and organizations have already adopted LoRaWAN protocol as a milestone towards a digital transformation. One such example is that of the Hamburg Port Authority. Sensors are installed along the bridge of the port and LoRa enables precise and predictive maintenance and repairs planning. Let's have a look at some of the advantages that the LoRaWAN offers over other wireless protocols. Local area networks such as Wi-Fi or Bluetooth are already established technologies. They have well-established standards such as Wi-Fi, Bluetooth 4.0, Zigbee, and Z-Wave. But the biggest problem with many local area network or personal area network is the battery consumption. Similarly, cellular network is also one of the well-established network, but fundamentally mobile networks like LTE was developed for better data throughput, and these networks are not best when it comes to power consumption. Low power wide area network, on the other hand, are built from ground up. LoRa is developed to work only with IoT devices which needs best in battery life. Also, LoRa kind of network require minimal cost for deployment. In contrast, both LAN and cellular networks are quite expensive to deploy in a wide area, for example, to cover a whole city. These are some of the references that we used to produce the presentation. I hope you have enjoyed the presentation. Thanks a lot for your time.